Okay, radical expressions. Radical expressions means we're going to be simplifying roots, square roots, cube roots, things like that. So, you know how to do square roots. I know you know how to do this. You've done things like this before. A square root is basically undoing something that you squared. So if I have 4, what do I square to equal 4? And the answer is 2. So we know the square root of 4 is 2. We know the square root of 81 is 9. 9 times 9 is 81. We know the square root of 16, I hope, is 4. 4 times 4 is 16. Now, if you have a fraction under a square root, you can write it like this. And in our next few sections, we're going to do more of this. But if you've got a fraction, now it only works if you got, if you got a fraction, you take the square root of the top and you take the square root of the bottom separately. Later on, we're going to do this. It's not going to come out to be a nice number, but this is what you do. You split it apart. All right, let's do some more. Now, if you've got a square root, you can never have a number underneath it. Now, as a matter of fact, if your root is an even number, like a 4th root, or a 6th root, or an 8th root, you can never have a negative under there. So if your root is a even number, you can never have a negative sign underneath. If you do, your answer is no solution. Now, sometimes you're going to have operations underneath the square root. We cannot have pluses or minuses under a square root. So what you have to do is you first add the numbers underneath the root symbol. Then you take the square root. So you always do what's under the root symbol first. So you subtract these two numbers. Then you take the square root. Now, so don't do it separate. Add them first, and then take the square root. Now, I want to make sure you understand this. A square root right here is understood. It's a little 2. Square root means 2. So let me just write. So this is called the index. The index of a root is what the root is. A square root, the index would be 2. All right. If we have a cubed root, the index is 3. If we have a 500th root, the index is 500, and that's going to come into play later on. So I want you to know what the index is. It's the number of the root. Okay. When we're simplifying variables, the easiest way I can tell you is to take the variable and divide it by the index. So if I've got a square root, I'm just cutting the variables in half. I'm cutting the exponents in half. The square root of x squared is just x. The square root of x to the 4th is x squared. The square root of x to the 10th is x to the 5th. Square root of x to the 50th is x to the 25th. You're dividing the exponents by the index, and the index of a square root is 2. Now let me write down here. If, let's say I had x to the 6th, y to the 12th. there's two variables. We divide the exponents by the index, which is 2, so we'd get x cubed y to the 6th. This is going to be important later on too, because we're going to end up doing this later on, but they're not going to go in there evenly. But for right now, you divide the exponent underneath by its index. Now, evaluating square root functions. We have not talked about what this is. College algebra, you will talk about this a lot. When it says evaluate, that means plug a number in for x. We're doing a substitution. Now, a function is written a certain way, and we're told what to plug in for x a certain way. Now, this is called function notation. This is telling you to evaluate the function. When it puts a number in the parentheses, that's telling you the number to plug in for x. It'll give you this, and then it'll ask you to find something like this. So we've got a 16. We're going to put a 16 underneath the radical sign. And we're going to add the two numbers together. Then we're going to take the square root. So you'll be told what f, that's how you read this. Let me write that up there. This is read f of x. If you're given that notation and you're given a little formula, you're going to be asked to find for a specific number. Here's another example. F of x is this formula. It wants me to find what we call, how you read that is f of 2. Which is just a fancy way of saying, hey, substitute that 2 right here. Now, you have to simplify everything under the square root before you do anything. I can't stress that enough. If you can multiply, add, and subtract, you do all that first. Then you take the square root. In this case, the square root of 9 is 3. So don't overcomplicate this. It'll give you this, and then it'll give you a number to substitute in. Alright, let's talk about cubed roots. Cubed root is undoing a number cubed. You know, what do we multiply a number by itself 3 times to equal something? Now, a cubed root has an index of 3. So think back to chapter 6 when we were doing those difference in sums of cubes when we were factoring. You know, we had to multiply a number by itself to equal something. So, you know, I look at this and I say, okay, what do I multiply by itself 3 times to equal 8? And the answer is 2. So the cubed root of 8 would just be 2. What do I multiply by itself 3 times? Alright, let's say I had the cubed root of, 125. What do I multiply? 3 times by itself to equal 125. And the answer is 5. Say I had the cube root of 27. What number times itself 3 times equals 27? Well, 3 times 3 times 3. So the answer is 3. you can have a negative sign under a square root symbol. Under a cubed root symbol. It will be a negative. If your root is odd, if the index is odd, you can have a negative number under the square root. So looking at this one, the cubed root, under the root, not square root, under the odd root. All right. So what number times itself equals 64? 4 times 4 times 4. So this would be negative 64. Let's say I had the cubed root of, 1,000 over, oh, what the heck, we'll just do 27 again, I guess. Well, it's a fraction, so we can break it apart. Whoops. Take the cubed root of 1,000, then take the cubed root of 27. Well, what number times itself 3 times equals 1,000? Well, that's 10. And then 27 would be 3. For variables, you're going to do the exact same thing that I did for the square roots. You're going to take the exponent and you're going to divide it by the index. 3 divided by 3 is 1, so you'll have x. If I have the cubed root of x to the 15th, 15 divided by 3 is 5, so we'll have x to the 5th. If I had 2 variables or 3 variables, say I had x to the 9th, y to the 12th, z to the 30th. We divide all the exponents by 3. So we'll get x cubed y to the 12th, not 12th, y to the 4th, z to the 10th. So whatever exponent is underneath, you're going to divide it by whatever this index is. Alright, we will have cubed root functions. Cubed root. And we'll be asked to simplify that. I'll be told a number here. And that number goes where the x is. So in the parentheses in this problem, we're going to put a 6. Now, we add the numbers underneath before we do anything. 2 plus 6 is 8. Then we take the cubed root of 8, which we've already said was 2. Let me do one more of those. So let's say f of x was equal to, the cubed root of x minus 17. And I want to find f of 30. I meant to do that in red. So wherever the x is, I'm going to put a 30. So let me rewrite it. I don't think it's 30. Well, let's just see what happens. Hold on. Make that, let's change that to a different number. 27. let's do 40. I know what I want to do. I want to change this number to a 10. Yeah, let's change that to a 10. And I want to find the function value for 37. So I want 37 here, which means in my parenthesis where the x is, I'm going to put a 37. All right. Let's simplify what's underneath. 27. And then we take the cubed root of 27, and we know 3 times 3 times 3 is 27, so the cubed root is 3. So this is nothing super complicated. Maybe you haven't done, I know you haven't done these functions before, but you're just plugging a number in, adding or subtracting or multiplying underneath, then taking the root. All right, that should be it for right now. Do the homework.